Hello dear students, welcome one and all to first PUC Tungal online classes. In this session, we will discuss concern to calorimetry and the latent heat of the matter. Let us start our concept from calorimetry. Concept is calorimetry. The branch of science which deals about measurement of heat, that branch we are calling calorimetry, and the device which measure the measurement of heat of the system, that device we are calling calorimeter. Shall I go here? The branch of physics, which deals about measurement of heat, measurement of heat is called as calorimetry. The device which measure the measurement of heat is called as calorimeter. See here. Calorimeter. It is a device to measure the heat of the system. Then how calorimeter made up and how the calorimeter works, on what principle, we will explain in detail. Calorimeter is made up of copper vessel containing lead and stirrer, and it is placed in wooden block to avoid the loss of heat. Shall we see the construction, how it is looks like? Calorimeter, it is made up of copper vessel. This is the copper vessel, right? Copper vessel level. This we are calling copper. This is the copper vessel. The copper vessel provided with stirrer and lead. This is the stirrer I can call. Stirrer. Right. This copper vessel placed in a wooden block to avoid the loss of heat, and this calorimeter, let us consider it contains some amount of hot liquid. Right. To understand the concept of principle of calorimeter, we know that before it, in a temperature is in a hot condition and another system is in cold condition. I will take two systems, one is hot system, second one is cold system. When hot system made physically contact with cold system, heat transfer from hot system to cold system. Still, temperature of both system remains same. I mean, the hot system loses amount of heat, the cold system gain the amount of heat. In this case, the heat lost by the hot system must be equal to heat gained by the cold system. Directly, the principle of calorimeter is the heat lost by the hot system must be equal to heat gained by the cold system. This is the principle of calorimeter. Principle of calorimeter says what principle? Heat lost by the system. Heat lost by hot system is equal to heat gained by cold system. Heat gained by cold system. This is principle of calorimeter. Then we already said that when hot system made physically contact with cold system, heat transfer from a hot body to cold body, still the temperature of both system remains same. The temperature of both system remains same. That temperature we are calling common temperature. Shall I say here? I will take two system. Let us consider it is a hot system. Hot system. This system has mass m1, specific heat capacity C1 and temperature T1. Shall I take? It is hot system. Right. Now I will take cold system. This is the cold system I will take. This cold system has mass m2, specific heat capacity C2 and temperature T2. What are calling? This is the cold system. When hot system made physically contact with cold system, what happened? See here. The hot system made physically contact with cold system. This we are calling hot system, this we are calling cold system. Here mass of the hot system is m1, specific heat capacity C1, temperature T1. Here mass is m2, specific heat capacity C2, temperature T2. Then heat transfer from a hot system to cold system, still temperature of both system remains same. This temperature we are calling common temperature. Then how to calculate the common temperature, that we will see now. See here, the heat loss by the hot system, how much? Heat loss. In this case, what is heat loss? We know the heat is equal to mass specific heat capacity into change in temperature. For this hot system, how much mass is available? M1 mass, how much specific heat capacity C1, what is change in temperature? Final temperature minus initial temperature. See here, this is T1 minus T. Right. Similarly, heat gain by the cold system, how to represent? Heat gain by the cold system, heat gain. Heat gain, what is heat gain here? Mass C2, change in temperature. Here it is final, this is initial now. So I will take T minus T2, not T2 minus T. But what is the principle of calorimeter? The principle of calorimeter says that heat lost by the system must be equal to heat gain by the system. See here, heat loss. Principle of calorimeter, heat loss equal to heat gain. Equal to heat gain. See here, what is heat loss? Mass into C1 into bracket, how much? T1 minus T. Heat gain, how much? Mass specific heat capacity into how much? T minus T2. Right. Shall I solve this? From this I can get the common temperature T. How to solve? See here, M1 C1 into T1 minus M1 C1 into T. This is equal to, how to write? M2 C2 into T minus M2 C2 into T2. Are you following this? Shall I rearrange this? How to rearrange? M1 C1 T1, keep it up same. This term is inside. What we will get? M2 C2 T2 equal to. This term keep it up same. M2 C2 into T minus this term on the side. This becomes plus M1 C1 T. Right. In this what is common? T is common. In this case T is common. Then how to do? M1 C1 T1 plus M2 C2 T2 equal to. What happens here? M1 C1 plus M2 C2 into bracket how much? Capital T. Then what is capital T? Common temperature. How to calculate common temperature? Common temperature is M1 C1 T1 plus how much? M2 C2 T2 whole divided by how much? M1 C1 plus M2 C2. This is the common temperature T. The common temperature T you can calculate by using the principle of calorimeter. Later on we will see the change of state. Change of state. right. Next concept is change of state. Change of state. Students, generally we know that depending on amount of heat provided, depending on pressure and temperature, matter exists in three states. One is solid state, liquid state and gaseous state or vapor state. Change of state means the process of conversion of one state of substance into another state of substance. That process we are calling change of state. How to write? ಹೆಂಗೆ ಬರೀಬೋದು ಚೇಂಜ್ ಆಫ್ ಸ್ಟೇಟ್ ಅಂದರೆ ಒಂದು ವಸ್ತುವಿನ ಸ್ಥಿತಿನ ಇನ್ನೊಂದು ಸ್ಥಿತಿಗೆ ತರಬಹುದು. ಸಾಲಿಡ್ ಇದ್ದಿದ್ದು ಲಿಕ್ವಿಡ್ ತರಬಹುದು, ಲಿಕ್ವಿಡ್ ಇದ್ದಿದ್ದು ಗ್ಯಾಸ್ ತರಬಹುದು, ಅಥವಾ ಗ್ಯಾಸ್ ಇದ್ದಿದ್ದು ಸಾಲಿಡ್ ತರಬಹುದು. ಶಾಲ್ ಐ ಟೇಕ್ ಹಿಯರ್ ಚೇಂಜ್ ಆಫ್ ಸ್ಟೇಟ್? ದ ಪ್ರೊಸೆಸ್ ಆಫ್ ಕನ್ವರ್ಷನ್ ಆಫ್ the process of conversion of one state of substance one state of substance into another state is called as change of state. Is called as change of state. Change of state. Change of state means you can convert solid into liquid, liquid into gas, or gas into solid. Directly you can say. The change of state, it may be so many process. One is we are calling melting process. Second one we are calling freezing process, or we call vaporization process, or we are calling condensation process. Let us see one by one. See here. First process we are calling melting process. Melting process. Melting means the process of conversion of solid state into liquid state. That process we are calling melting process. Shall I see? The process of conversion of solid state into liquid state. This process we are calling melting process. See here, the temperature at which the solid state converted into liquid state, that temperature we are calling melting point of the substance. Melting point ಅಂದ್ರೆ ಒಂದು ವಸ್ತು ಯಾವ ಟೆಂಪರೇಚರ್ ಒಳಗೆ ಸಾಲಿಡ್ ಇದ್ದು ಲಿಕ್ವಿಡ್ಗೆ ಆಗ್ತದೆ ಆ ಟೆಂಪರೇಚರ್ ನಾವೇನು ಕರಿತೀವಿ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಹಿಯರ್ ಜನರಲಿ ವಿ ನೋ ದಟ್ ದ ice converted into water at a 0 degree Celsius. Ice converted into water at a 0 degree Celsius. I mean, during conversion of ice into water, temperature remains same. Mean during conversion of solid state into liquid state, they are in equilibrium condition. Both are in equilibrium condition because reason is there. During conversion of state of substance, always the temperature remains same, because when heat is provided to ice, whatever amount of heat provided to ice, all the heat is used to break the so many molecules of the ice. So there is no increase in kinetic energy. If there is no increase in kinetic energy, always the temperature remains same. ನಾವೇನು ಮಾಡ್ತೀವಿ, ಎಷ್ಟೇ ಹೀಟ್ ಕೊಟ್ಟರೆ ಐಸಿಗೆ ಆ ಎಲ್ಲ ಹೀಟ್ ಅದಕ್ಕೆ ಯೂಸ್ ಆಗ್ತದೆ, ಐಸ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ನ ಬ್ರೇಕ್ ಮಾಡ್ಲಿಕ್ಕೆ ಯೂಸ್ ಆಗ್ತದೆ. ಅದಕ್ಕೆ ನಾವೇನಂತೀವಿ, ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಏನೂ ಚೇಂಜ್ ಆಗೋದಿಲ್ಲ. ಅದಕ್ಕೆ ನಾವೇನು ಕರಿತೀವಿ, ಐಸ್ ಇದು ವಾಟರ್ ಕನ್ವರ್ಟ್ ಆಗಲಿಕ್ಕೆ ಟೆಂಪ್ರೇಚರ್ ಯಾವಾಗಲೂ ಕಾನ್ಸ್ಟೆಂಟೇ ಆಗಿರ್ತದೆ. ರೈಟ್? ಐ ಮೀನ್ ಡ್ಯೂರಿಂಗ್ ಕನ್ವರ್ಷನ್ ಆಫ್ ಸ್ಟೇಟ್ ಆಫ್ ಮ್ಯಾಟರ್, ಆಲ್ವೇಸ್ ದ ಟೆಂಪ್ರೇಚರ್ ಆಫ್ ದ ಸಬ್ಸ್ಟೆನ್ಸ್ ರಿಮೇನ್ ಸೇಮ್. Similarly, the reverse process I can call. Reverse process means the conversion of liquid state into solid state. That process we are calling freezing process. See here, freezing. Freezing process. What is freezing process here? The process of conversion of a liquid state into solid state at constant temperature. This process we are calling freezing process. Similarly here, the water is converted into ice only at a 0 degree Celsius. How to convert water into ice? If it is extracted from the water, so that the water is converted into ice. During extraction of the heat, all amount of heat extracted is used to make the bond between so many ice molecules. As a result, again, there is no change in kinetic energy, so that the temperature during conversion of water to ice remains same. So either you can convert solid into liquid or liquid into solid, always temperature remains same. Students, we say that the temperature at which solid state is converted into liquid state, that temperature we are calling melting point of the substance. The melting point of the substance depends mainly on three factors. One factor is the nature of the material. Different material melts at a different temperature. Water melts at 0 degree, some other material melts at some other temperature. And melting point depends on pressure. For liquid exactly, I am saying. For liquid, if we increase the pressure, melting point is decreased. Melting point of the liquid is decreased with increase in pressure. Similarly, the melting point also depends on impurity present in it. ಈ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಮೂರು ಪ್ರೊಸೆಸ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆದ ರೀ. ಒಂದು ನಾವೇನು ಕರಿತೀವಿ ನೇಚರ್ ಆಫ್ ಮಟೀರಿಯಲ್ ಅಂತ ಕರಿತೀವಿ, ಪ್ರೆಷರ್ ಅಂತ ಕರಿತೀವಿ, ಇನ್ನೊಂದು ಇಂಪ್ಯೂರಿಟಿ ಅಂತ ಕರಿತೀವಿ. ರೈಟ್, ರಿಮೆಂಬರ್ ದಿಸ್ ಪಾಯಿಂಟ್ ಈಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. The melting point is a decreases with increase in temperature, with increase in pressure. Right, after this one more process we will see, vaporization. See here, vaporization means the process of conversion. The process of conversion liquid state into gaseous state at constant temperature. This process we are calling vaporization. How to do? The process of conversion of liquid state of the substance into gaseous state at constant temperature. This process we are calling vaporization. See here example I can take. The water H2O. Water is converted into gas or vapor exactly at 100 degrees Celsius. Exactly at 100 degrees Celsius, water is converted into ice. I mean, during conversion of water into gas, always the temperature remains same, because reason is there. After 100 degrees Celsius, whatever amount of heat provided, this amount of heat is used to the bond between hydrogen and oxygen, because here oxygen and hydrogen bond is there. So there is no change in kinetic energy of hydrogen and oxygen. That's what during conversion of water into gas, always the temperature remains same. And the temperature at which the solid or liquid state is converted into gaseous state, that temperature we are calling boiling point. Boiling point means at what temperature the liquid state is converted into gaseous state, that temperature we are calling boiling point of the substance. The water generally boils at 100 degrees Celsius. Water ಎಷ್ಟು temperature ಒಳಗೆ ಬಾಯ್ಲ್ ಆಗ್ತದೆ ರೀ? 100 degree ಒಳಗೆ ಬಾಯ್ಲ್ ಆಗ್ತದೆ. Then the temperature at which the liquid state is converted into gaseous state, that point or that temperature we are calling boiling point of the substance. Boiling point. See here, this is important, boiling point. The boiling point of the substance mainly again depends on three factors. One is nothing but pressure, second one is nature of material, and third one is impurity. Different material boils at different temperature. Water boils at 100 degrees Celsius, some other liquid boils at some other temperature. But in between pressure and boiling point there is the relation. If pressure increase, definitely boiling point also increase. I mean, if pressure increase, the temperature of the substance will increase. See here, this pressure, what I am saying, the pressure directly proportional to boiling point means temperature. This is the one of the reason on which your pressure cooker works. In pressure cooker, what happen? If more the pressure, temperature increase, hence boiling point also increase. Remember, these 2 points are important. Melting point depends on pressure. If pressure increase, melting point decrease. But if pressure increase, what about boiling point? Boiling point will increase. Remember this point. These are very important. Right. What I said here? The process of conversion of liquid state into gaseous state, that process we are calling vaporization. On other hand, the reverse process I can call. Reverse process means conversion of gaseous state into liquid state. This we are calling condensation. Condensation I can call. See here. Shall I call the one more process? Condensation. Condensation. What is condensation? The process of conversion of gaseous state into liquid state at constant temperature. We know that again. The water converted into the gas converted into water only at 100 degrees Celsius. See here. Water, gas you can call. The gas is converted into water only at 100 degrees Celsius. So that here also during conversion of liquid into gas, temperature is 100 degrees Celsius. Again during conversion of gas into water, temperature is 100 degrees Celsius. I mean during conversion of state of matter, either solid to liquid, liquid to gas, always temperature remain same. Right. But here one more process is available. What we have done? We can convert a solid into liquid into gas. Simply I am calling, if we convert solid into liquid, that we are calling melting. If we convert liquid into solid, that we are calling freezing. On other hand, if liquid is converted into gas, that we are calling vaporization. Reverse process, if the gas is converted into liquid, that process we are calling condensation. But here one more process is available. That process we are calling sublimation. Shall I see the concept of sublimation? Look at me. Sublimation I can call. Sublimation. Sublimation means the process of conversion of solid state into vapor state without converting into water. I mean without converting into liquid state. That process we are calling sublimation. Andre solid na direct agi vapor convert madodri. Ee process ನಾವು ಏನು ಕರೀತೀವಿ? Sublimation ಅಂತ ಕರೀತೀವಿ. Shall I see here? Some materials are available. Arsenic is there, iodine is there. If this material left in the atmosphere, directly they convert solid into gas. ನಾವು ಕರ್ಪೂರ ಅಂತ ಕರಿತೀವಿ. ಕರ್ಪೂರ ಏನು ಮಾಡ್ತದ್ರಿ? ಸಾಲಿಡ್ ಇದು ಡೈರೆಕ್ಟ್ಲಿ ಗ್ಯಾಸೇ ಆಗ್ತದೆ. ಈ ಪ್ರೊಸೆಸ್ ನಾವೇನು ಕರಿತೀವಿ? ಸಬ್ಲಿಮೇಷನ್ ಅಂತ ಕರಿತೀವಿ. ಸಬ್ಲಿಮೇಷನ್ ಮೀನ್ ದ ಪ್ರೊಸೆಸ್ ಆಫ್ ಕನ್ವರ್ಷನ್ ಆಫ್ ಅ ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಇಂಟು ಗ್ಯಾಸಿಯಸ್ ಸ್ಟೇಟ್ ಡೈರೆಕ್ಟ್ಲಿ ವಿತೌಟ್ ಕನ್ವರ್ಟಿಂಗ್ ಇಂಟು ಲಿಕ್ವಿಡ್ ಸ್ಟೇಟ್. ದಿಸ್ ಪ್ರೊಸೆಸ್ ವಿ ಆರ್ ಕಾಲಿಂಗ್ sublimation. Then sublimation, it may occurs naturally for some substance. To undergo sublimation, we have one condition. The condition is the material must have weak intermolecular force, and second one is they have more ionizing power, more ionizing or more vaporization power. Where it is occurred? Sublimation occurs in the material in which the material having a low intermolecular force and they have more ionization power, then only sublimation occurs. Or directly, if a much pressure increase on some material, much more pressure increase, directly the solid is converted into gas. I mean, to occur the sublimation, three conditions are there. One must be the material must be having low intermolecular force. Second one, the material must be having more ionization power or vaporization power. Third one is the pressure on the material must be very high. Then only the solid can convert into vapor directly. This process we are calling sublimation. And the temperature at which the solid is converted into gas, that temperature we are calling sublimation point. That temperature we are calling sublimation. But students, to convert solid into liquid, liquid into gas or reverse, we require some amount of heat. heat is needed to convert solid into liquid, liquid into gas, right? Then on this basis we will see the one more concept is the latent heat, or we can call it hidden heat. Shall I see the hidden heat or latent heat? See here, concept is latent heat or hidden heat. Latent heat or hidden heat. Latent heat. See here, to convert one state of substance into another state, we require some amount of heat. Simply, latent heat means the amount of heat required to convert one state of the substance into another state. That process we are calling latent heat. I mean, amount of heat required to convert solid into liquid, or liquid into gas, or gas into liquid. This process, this concept we are calling latent heat or hidden heat. Or simply, latent heat is amount of heat required per unit mass to convert one state into another state. Already we know that during conversion of one state of the substance into another state, always temperature means same. See here, shall I go first definition of latent heat? In what way I can define? Look at me, latent heat mean what? The amount of heat required to convert one state of substance into another state at constant temperature. The amount of heat required. The amount of heat required. Heat required per unit mass. Per unit mass. To convert one state into another state of substance. To convert one state into another state of substance. Into another state of substance. Another state of substance. Another state of substance is called as latent heat. Latent heat. The latent heat, it is represented by quantity L. Quantity L. How to define? The amount of heat required per unit mass to convert one state into another state at constant temperature, I can call. See here, the latent heat, either it is latent heat of melting, or latent heat of fusing, latent heat of vaporization, or latent heat of condensation. One by one we will see the general formula for this. Before the latent heat, what is the SI unit for this? Latent heat. Q is nothing but heat. Heat is measured in joule, mass is measured in kg. What is SI unit? Joule per kg for latent heat. Shall I add the dimensional formula of this? See here, how the dimensional formula? Heat is nothing but energy. Energy dimensional formula ml square T raised to minus 2 divided by how much? Mass. This one get cancelled. Then what is latent heat formula? Latent heat is equal to how much? L square T raised to minus 2. Don't confuse. L mean here latent heat. Capital L mean dimensional formula of the length. Right? Latent heat may be latent heat of melting, latent heat of fusing, or latent heat of vaporization. Shall I see one by one? Latent heat mean? Look at me. See here, latent heat of melting I can call initially. Latent heat of melting. latent heat of melting. Latent heat of melting represented by Lm. Latent heat of melting means the amount of heat required to convert solid state into liquid state. This we are calling latent heat of melting. How to represent latent heat of melting? Latent heat of melting is amount of heat required per unit mass to convert solid state into liquid state. For example, to convert ice into water, we required 80 calorie per joule. See here, shall I take? To convert ice into water, how much amount of heat is required? 80 calorie per gram is required. I mean per gram, if we convert the ice into water, we need 80 calorie of joule. Water na ice convert ಮಾಡಬೇಕಂದ್ರೆ per gram ಎಷ್ಟು heat energy ಬೇಕ್ರಿ? 80 calorie ಬೇಕು. Shall I see the graph of heat versus temperature? See here, for this shall I see here heat versus temperature, I will draw here only. See here, along x-axis shall I take the temperature, along x-axis shall I take the heat, along the y-axis shall I take the temperature. I will take the temperature here. Look at me, how to take? To convert ice into water, but during conversion of ice into water, what is temperature? Always temperature remains same, 0 degree. We know that during conversion of one state of matter into another state, always the temperature remains same, right? Shall I see here? I need 80 amount of calories. Here it is nothing but 80 calorie of joule. This is 0 degree temperature. This is the 0 degree. Shall I call 0 degree? Here how much amount of it is there? 80 calorie. This may be 80 calorie. 80 calorie amount of joule. But here what is the temperature? Temperature is 0 degree Celsius. Right? When water heated from 0 to 100 degrees Celsius, its temperature changes. How the graph may be possible for water? Like this graph may be possible. What about this? This we are calling melting. Here how much temperature available? 100 degrees Celsius available. Right? When ice convert into water, later on the temperature of the water increases up to 100 degrees Celsius. At this point, the water start to boil. Right? What I call a latent heat of melting. Similarly, you can define latent heat of fusing. Latent heat of freezing I can call. Freezing means if 80 calorie amount of it is extracted from the water is converted into ice. I mean amount of it extracted to convert ice into water, that process we are calling a latent heat of fusing. Shall I define latent heat of fusing here? How much? Shall I represent by LF? How much? Amount of it required per unit mass. What happens? It is the water is there. Look at me, it is water. Water is converted into ice. What to do? If we extract 80 calorie per gram, at what temperature? 0 degree Celsius. I want to extract this much amount of it from the water, then water convert into ice. Water ಯಾವಾಗ ಐಸ್ ಆಗ್ತದ್ರಿ? ನೀವು 80 ಕ್ಯಾಲೋರಿ ಎನರ್ಜಿನ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ ವಾಟರ್ ಒಳಗಿಂದ ಅವಾಗ ಏನಾಗ್ತದ? ವಾಟರ್ ಇದ್ದಿದ್ದೇನಾಗ್ತದ? ಐಸ್ ಆಗ್ತದ. ಈ ಪ್ರೊಸೆಸ್ ನಾವೇನು ಕರಿತೀವಿ? ಲ್ಯಾಟೆಂಟ್ ಹೀಟ್ ಆಫ್ ಫ್ಯೂಸಿಂಗ್ ಅಂತ ಕರಿತೀವಿ. Reverse of latent heat of melting. Later on, we can convert liquid state into gaseous state. To convert liquid state into gaseous state, we need some amount of heat. On that, we are defining the one more physical quantity. The physical quantity is latent heat of vaporization. Latent heat of vaporization. Right. The latent heat of vaporization, it is represented by what quantity? Latent heat of vaporization can be represented by LV. How to do? The amount of heat required to convert liquid state into gaseous state. That heat is we are calling latent heat of vaporization. Shall I call here? the amount of heat required per unit mass to convert liquid state into gaseous state. See here, how to call? To convert liquid state into gaseous state. Liquid state into gas. Liquid state into gas. Shall I call here liquid state into gas? To convert liquid state of water at 100 degrees Celsius into vapor state, we need 40 calorie per gram. Remember here, this process what you are calling? The amount of heat required. Amount of heat required here. How much amount of heat required? The heat required to convert liquid state into gaseous state, that process we are calling latent heat of vaporization. See here, to convert water into gas, we need how much amount of heat? We need a 40 calorie amount of heat. If water is at 100 degrees Celsius, at what actually? Water start to boil at 100 degrees Celsius. When water reaches at 100 degrees Celsius, if we provide more amount of heat, how much amount of heat? 40 calorie amount of heat, then the water is converted into gas. Right. But here reverse process I can do. If 40 calorie amount of heat is extracted from the gas, again the gas is converted into water. That process we are calling latent heat of condensation. Aduk naವೇನು ಕರಿತೀವಿ? Latent heat of condensation ಅಂತ ಕರಿತೀವಿ. Reverse I can call here. Reverse means shall I take here? Latent heat of condensation represented by LC. How to see? Amount of heat extracted. What to do here? The gas is converted. Gas is converted into water or liquid. Here what to do? Temperature is at 100 degrees Celsius. What amount of heat is extracted? 40 calorie amount of heat is extracted. See here. After 100 degrees Celsius, temperature always remains same. And what about heat? Heat is nothing but water. This value, this is what we are calling vaporization. Vapor I can call. Here how much amount of heat is there? 40 calorie amount of heat is there. Here how much amount of heat is there? 80 calorie amount of heat is there. I mean, to convert one state into another state, we require some amount of heat that we are calling latent heat. The latent heat may be latent heat of melting, latent heat of freezing, or latent heat of vaporization, condensation. Right. These are the concept concerned to latent heat. After this, students, I said somewhere, melting point depends on pressure and the boiling point depends on pressure. For liquid I said, what I said here? When boiling point increases, temperature also increase. Right? I mean, pressure increases, directly boiling point increase. But if the pressure decreases, what about boiling point? What about melting point? Melting point is decrease. If pressure increase, melting point is decrease. On that basis, we will see the one more process. That process used in skating. That process we are calling regulation. That process we will see here. Regulation. See here, the concept is regulation. Regulation. See here, in winter season generally the all water converted into ice. There we are going to skating. During skating, the ice always remain ice, it does not convert into water. Regulation mean the melting and refreezing of water. The melting of ice and refreezing, this process we are calling regulation. Melt agi matte freeze agodri, ee process naವೇನು ಕರಿತೀವಿ regulation ಅಂತ ಕರಿತೀವಿ. Shall I define the regulation first, then we will go in detail. The process of melting and refreezing is called as regulation. Is called as regulation. See here. To understand the concept of regulation, I will take ice cube. The ice cube is suspended by very heavy mass. By two heavy mass I will take. Look at me. I will take, this is the ice cube. I will take ice cube. In the ice cube I will take two high masses I will take. These are the high masses. Shall I take? This mass I can take. Mass I can take. This is a 10 kg mass. What about this? This also 10 kg mass. Remember, both are the same mass. Both are 10 kg masses are available. Right. After some time, this hanging wire passes across the ice cube without breaking the ice cube. Andre ಇವೆರಡು ವೇಟನ್ನು ಹೆಂಗೆ ಮಾಡೀನಿ, ಸಮ್ ಟೈಮ್ ಆದಮೇಲೆ ಈ ವೈರ್ ಏನಾಗ್ತದೆ ಐಸ್ ಒಳಗೆ ಪಾಸ್ ಆಗಿಬಿಡ್ತದೆ, ಬಟ್ ಐಸ್ ಮಾತ್ರ ಕಟ್ ಆಗೋದಿಲ್ಲ. ಬಿಕಾಸ್ ಫಾರ್ ರೀಸನ್ ಇಸ್ ದರ್. ರೀಸನ್ ಈಸ್ ವಿ ನೋ ದ್ಯಾಟ್ ದ ಪ್ರೆಷರ್ ಡಿಪೆಂಡ್ಸ್, ದ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ಪ್ರೆಷರ್. If pressure increase, what about melting point? Melting point decrease. Shall I take? If the pressure increase, what about melting point? Melting point decrease. This phenomena works here. See here, exactly at this point, due to the wire, the pressure increase. At this point, the pressure increase. Then what about melting point? Melting point decrease. The ice is converted into water at this point. The converted water again comes up and it refreezes due to removal of pressure. Where the pressure exists? Only at this point pressure exists. Due to pressure, the ice is converted into water and the water comes up again refreeze. For example, again if the wire is here, at this point wire is there. Due to much amount of pressure, the ice is converted into water due to decrease in melting point, and the water melted come up again refreeze. Actually what happened? When wire passes slowly, melting point decrease, as a result ice is converted into water. The converted water again come up the wire and it refreezes due to removal of this pressure. Only where pressure exists, at this point pressure exists. Due to pressure melting point decrease, ice converted into water. Again the melted water comes up, again refreezes due to normal atmospheric pressure. So that if you place a wire on the ice cube, the wire passes without breaking the ice cube. Because of what? This phenomena. As pressure increases, melting point of the water is decreased, or melting point of the ice is decreased. So this process, what I can call? The process of melting and refreezing is called as regulation. Students, one more concept is that I said that the boiling point increases with increase in pressure. ನೀವು ಹೆಂಗನ ಪ್ರೆಷರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತೀರಿ ಹಂಗೆ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಏನಾಗ್ತದೆ, ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಅಂದ್ರೆ ಏನು? ಟೆಂಪ್ರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ. ದ ವೆರಿ ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಫಿನಾಮಿನಾ ಇನ್ ದ ನೇಚರ್, ದಟ್ ಈಸ್ ಅ ಟ್ರಿಪಲ್ ಪಾಯಿಂಟ್. ದಟ್ ಕಾನ್ಸೆಪ್ಟ್ ವಿ ವಿಲ್ ಸಿ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್. ಇಟ್ ಈಸ್ ಆನ್ ದ ಬೇಸಿಸ್ ಆಫ್ ಇಫ್ ದ ಪ್ರೆಷರ್ ಇನ್ಕ್ರೀಸ್, the boiling point of the matter or boiling point of the liquid is increase. On that phenomena we will see tomorrow. We will continue the triple point of the water in tomorrow's class. Now we will stop. Thank you students. We will continue in the next class.